Hey everybody, today I just wanted to do a quick video on how we can build an EXE in LabVIEW from our code. So, in LabVIEW we can set up all of our VIs, our classes, our custom controls, etc. But typically, right, we want to deploy this as an EXE. So there's a whole bunch of advantages to using EXEs. Someone can't haphazardly go in and modify your source code. Either accidentally or it could even be maliciously, right? They could be trying to cause something bad to happen. So an EXE can kind of prevent that because it's no longer editable and it's just compiled code. It also kind of builds in all of your dependencies and everything into that file. So you could have a couple of VIs, you could have hundreds of VIs, you could be pulling in different libraries from VIPM, from VILib, etc. Basically, you can take all of those components and build them into one single file. So you don't need to, if someone needs to run your code, right, they don't need to go install all these packages from VIPM and whatnot. Everything's just compiled and built into that application. Big advantages. And you can also go distribute this. All the EXE needs is basically the runtime engine, which is free. Anyone can use it without licensing and whatnot. And whatever drivers are necessary for your specific application. So it could be the DAC-MX drivers, could be iMac drivers, could be Visa drivers. But again, all of that stuff is free. So you don't need basically LabVIEW licensing to run your code all these different locations. To create an EXE, we're just going to go down to Build Specs, go to New, and select Application EXE. So we get this little dialog. So we have a couple things on this first page. We have this build specification name. This is basically in our project under Build Specs what is going to be listed. So I'm just going to call this Demo EXE. I can then specify the name of my EXE that I'm going to build. You can call it whatever you want, really. I'm just going to call it that because that's what this project is. Next, we need to specify where we want this built. So you can enter a path here. You can click the little file dialog to select one. You also can just go and drag a directory in there. And then we can also include a description as well here. Next, we need to include our source files. So we always need to have some sort of startup VI. And so there's typically two things that you're putting in the startup VIs. So either this is going to be your top level VI, which in this case is what we're doing. When this EXE gets called, this is the VI that's going to start running. And now it's going to go call, it can go call all of these other component VIs and custom controls and classes and libraries. But the top level, is typical to be put in your startup VIs. Now there's one other thing I've used before aside from top level, and that would be when we set up like a splash screen that will then call the top level separately using like VI server. So that would be the one exception to that I've seen is when you're setting up a splash screen. So sometimes you might have like a really big application, right, that has to load tons of different classes and libraries and all sorts of stuff, and the load time can kind of take a while. So one way you can kind of make things seem quicker and more responsive is instead of loading your main VI, load a little splash screen. So it loads really quickly. It has very little dependencies, but then it can go it can load your main application in the background, and once it's done loading, it can display that and close itself out. So typically, you're going to want your top level. I would say the exception would be when you're using like a splash screen like that. Now there is also this always included section. Now typically you don't need to include anything here. Everything that's statically linked, so all of these sub VIs are statically linked in our main. They're automatically going to be included as dependencies. I don't need to worry about that. So the only things you might need to include in the always included is stuff that isn't automatically linked to your application. So that could be like VIs that you're calling dynamically. You're basically passing a path to a VI and it's loading that VI and calling it. That's stuff that you would want to include in always included, so that this can make sure that it includes those VIs with your build in like a support directory, and also that they have compiled code in them so that they can be called dynamically. So, and if there's other stuff that you wanted to include, right? For example, if I have some sort of image or documentation or whatever that I want to go with my EXE in that kind of support directory, I can also add those as always included. But yeah, for the most part, you don't need to go, add all of these VIs to your always included, because by default they're automatically included because they are statically linked in your main. Next, we have this destinations. So our first destination, is our actual EXE. And we've just defined the path here. Not very many options I can configure. I can add files to a new project directory if I want to, but and then there's also this support directory. So like I said, anything included is going to go in this data folder that is relative to your build location. So this will be things like DLLs that are called by your system that need to be included, and other things that you've included in the always included. We'll go to the support directory. And by default, it is data relative to your build. If you want to, you can change that. Next, we have source file settings. So I can go to VIs, and I can basically override details of those VIs. So if I go to this VI, for example, and customize VI properties, by default, everything is going to use the VI properties. So basically, however that VI is configured to work in LabVIEW is how it's going to work in the EXE. The big difference is you get this run when opened is automatically checked, because in an EXE, you don't want to load a VI and go click a run button for it to actually do something. People are just expecting it when it opens to start running. So that would be the one exception there, is that is automatically checked. But yeah, everything else here is basically pulling the behavior of how the VI is configured. If I want to, I can uncheck that, and I can then override, that behavior. So, I can go customize this. I can go customize, window behavior, stuff like that. How it opens, etc. So you can kind of customize that however you want, and you can go in and you can override all of your VI's behavior. You also can include icons. By default, you get a LabVIEW icon, and it looks a little different depending on the version of LabVIEW you're using, but that's going to be the default icon, and you can specify the size of that depending on what you want. But yeah, that's basically the default icon. Basically, what will show up, on the toolbar or on the desktop, etc. Now you also can go to the icon editor and edit icons, so you can go kind of create custom icons this way. So I can put text, I can put colors, I can import icons, stuff like that. So I can kind of create custom icons that way. If you want to use a custom icon, just uncheck that default icon. And you also can just go download ICO files. So if you go online, there's a whole bunch of different free icon files you can use. So I'm just going to check that one. So yeah, now my icon will be like this. So I found that that's the best way to get professional looking icons, is to reach out and find people who have done it and created nice looking icons. The icon editor works, but it's not super easy to use, and it's a lot of work to create icons. So I find I don't use it very often, but typically I will just go online to try to find icon files that are free and royalty free especially, and then basically include them there. Now, when we go to advanced, here you can control some different kind of advanced settings. The most important ones I would say is this enable debugging. So if you want, you can enable debugging in your EXEs, which means basically you'll be able to not necessarily do debugging on the machine where the EXE is running, but from a remote machine that has LabVIEW installed on it, you can connect to that EXE and you can view its block diagram. You can use debugging tools, like breakpoints and probes and stuff like that to see what's going on. But you do take a performance hit, and your EXE is going to be a lot bigger if you do this. So unchecking this will improve performance quite a bit. But there are times where you want that debugging enabled so you can kind of troubleshoot your build. So it depends on what you're trying to do. Typically, though, you're just going to want to make sure that that's debugged after you've done your initial debugging, right? So maybe like your first build, it can be helpful to include this so that you can kind of make sure it's working correctly. But once you've got things stable, it's a good practice to just uncheck this. There's a whole bunch of other options. There's a pass all command line arguments to application. If you want to work kind of over the command line, you can enable ActiveX, which is disabled by default. And another big one is down here, allow future versions of the LabVIEW runtime to run this application. So this is one that can be helpful to run. So for example, I'm in LabVIEW 2021 right now. I can build this in LabVIEW 2021, which means it's going to require at least LabVIEW 2021 runtime. But if, for example, someone had LabVIEW 2023 runtime installed, they would actually be able to still run this application even though it was built in LabVIEW 2021. So it can be a handy feature. There also are these additional exclusions. These are basically ways to kind of help optimize your builds. So like, for example, disconnecting type definitions. Type definitions are really helpful in the development environment. They can make, updating your code, so much easier and, reusable. But in an EXE, it doesn't really serve any purpose, right? So I can just disconnect that, and it no longer has to treat it like it's something special. It can just treat it as the native data type. Same thing with like unused polymorphic VI instances. So, I could have a polymorphic VI that has 10 instances, but maybe in my code, I'm only ever using 2 of those. This will basically just remove the other 8 unused ones so that, it's less things that it needs to build into the EXE and keep track of. Same thing with unused members of project libraries. So if there's stuff that's included in a library, but I'm not actively using it in this project, it can just, remove it. And also unused inline sub-VIs. I can also exclude packed libraries and shared libraries as well if I want. I can go to version information, and I can specify a version number. And by default, this is going to auto increment. One thing to be aware of though, so you have kind of your major, your minor, your pitch, and your build. This auto increment is only going to increment your build. So for example, if I'm on 1.0.0.0 and I build this and then I build it again, you're only going to get this build number to increment. So if you want to actually change your major or your minor or your pitch / revision, whatever you want to call it, patch, you've got to go in and update these, or you can also programmatically update these as well if you wanted to. You've got a product name. You can do legal copyrights, company name, etc. Windows security. This is really something you should be doing from a security standpoint, depending on how your software is being used. But as security becomes more and more important, I think digital signatures become more and more important. By default, you don't need to. But if you can, I highly recommend you look into applying digital signatures. So basically, you can get a certificate issued from a certificate authority. Now, this isn't free. It does cost money. So, if you're a solo developer kind of doing things, on your own, maybe it doesn't make sense to spend the money. But, your company, you should probably look into purchasing one for you as a developer. And that'll just be in my certificate store. And then I can just select my certificate, and it will digitally sign it with my certificate that's issued from my certificate authority. You also can include a timestamp URL. So I typically use like the timestamp.digicert to basically timestamp that, and you can include a description URL. So basically the goal there is just to validate that the person that, the code that we're running was built by the person that we think it was built by, right? And we can say like, oh yeah, this is a valid source. And that way, if someone else were to get my code and go and try to build it, it wouldn't have my signature unless they also had my signature file, which was stored in my certificate store. So something I highly recommend that I feel like doesn't get done a lot. If that's something you're interested in, I would reach out to your IT teams about getting a digital signature issued from a CA. Another thing you can do is embed a manifest file. So basically you can build your own manifest file and embed it into your EXE that can basically define characteristics of how it behaves. So I've typically used this when I've created applications that I only want to be able to run as an administrator. Like maybe the functionality of the program just doesn't work if it's not run as an administrator. I can build a little manifest file, and I'll include this in another video just so you can see how you can do this. But basically write a manifest file, and then you can embed that into your EXE so that when they go to run it, it will basically force them to run it as an administrator. So it'll prompt them for admin credentials when they go to run it, instead of just being able to be run either way and not working if it's not run as an administrator. There is shared variable deployment. I am not a fan of shared variables, so I never use this. But if you need to deploy shared variables with your EXE, this would be where you go to do that. Runtime languages, so you can support specific languages or only certain languages. Web services, so if you're using web services, you can deploy web services with your EXE, and you can define basically which web server you want them to run on, and ports and certificates and stuff like that. So I can basically define how I want my web service to run and where it's going to run. I can define pre and post build actions, so I can create custom VIs that do things either before I build or after I build. So for example, I could create a VI that will automatically update the version for me. And before it builds, it will run that VI that will update the version. So rather than just auto incrementing the build number, I can actually set it so it will maybe from a file or from some sort of documentation know what version I'm building and update that, right? Or it could even be a GUI that like a little dialog that pops up and says, hey, enter the current build version number, right? What you want this to be. And you can also generate a preview if you go to preview. But yeah, we've got everything configured how we want. Let's click OK. So you can see I've got my EXE there. Let's build this. And depending on how big your project is, how many VIs are in it, this can take anywhere from a few seconds to quite a long time, right? Depending on how big your build is. But let's go open this up and see what it looks like. So we get our EXE. We also get this aliases file, and we get an INI file. The EXE is really what we're interested in, so I can go run that and take just a sec. But we're able to pop this up, and I now have my LabVIEW project running as a fully built application, as an executable. So, and it's a similar format whether you are doing this on Windows, whether you're doing this on Linux, Mac, etc. Format is essentially the same, but unfortunately there's no cross-compilation available. So if I'm on Windows, like I am right now, I can't build a application for Linux, for example. I need to be on a Linux machine. Now LabVIEW is cross-platform, so these VIs are basically platform independent, as long as I haven't included like platform specific functions on them. But the VIs themselves are not platform specific. So I can take this project, I can load it on a Linux machine, and then I can build it as a Linux application as well. So that's how you can build applications to run on Linux. That would basically be how you can build an EXE in LabVIEW. Thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.